Good morning, and thank you for joining us today. We'll be discussing virtual network implementation for your business and enterprise needs today. An executive summary: as we advance and grow at exponential paces, the ability for an enterprise to scale up efficiently and effectively is imperative in today's marketplace. Network implementation and expansion can often be costly and time-consuming, but we offer a virtual network solution to overcome these issues. By utilizing outside computing power and hardware, enterprises can now expand and navigate virtual spaces with ease, providing a seamless substitute for on-site affairs. So today we'll be discussing and deploying and configuring such a network to demonstrate how this is achieved. We'll be able to see what a network will look like for users and showcase its successful function in action in various modes. Next, we'll be testing the network to show its connectivity and security. And finally, we will show that while this type of network is excellent, there are some vulnerabilities to the end user that we must consider, especially for future network iterations. So let's get started here. Network implementation objectives and services rendered. So today we're going to establish a virtual network. We're going to test that network for connectivity. We're going to troubleshoot and resolve network connectivity in real time, identify key nodes in the system, test file transfer across the network, verify that new users can be added, test that an external network that's untrusted cannot intrude our current network, discuss vulnerabilities in this network, and then I'm going to give you some future recommendations and some final thoughts moving forward. So here is what the network that we're setting up, or that we've set up today, actually looks like in this network topology. So we've got, this is the user's PC, called the COPC here, and this is a Kali Linux machine that is the user adjacent. Here we have the demilitarized zone, which has the domain name server, the web server, and then a Kali, we're going to call this a Kali DMZ since it's in this zone. And this is just to look at these players here at a later time. Then we have the router, firewall router right here that serves as our hub. And then we've got the rest of the world, which is untrusted, and we want to safeguard our system from that. So this is what the virtual manager actually looks like. I'll show you at the end. I'll do a demonstration for you, but this is how the interface looks. It's a powerful virtual machine manager. It can handle multiple interfaces at once. And as you can see here, I've got 7 that coordinate with the previous topology diagram that shows those 7 nodes. So this is just to show that they have been loaded and are ready to be utilized. And that's what the user will also see. So the very first thing we're going to be tasked with doing, or I was tasked with doing, is test for network connectivity. So I went ahead and tried to log into the CEO PC, and it does not want to connect with the DNS server. So the issue here could be a possible resolution in the network connection settings. So we're going to take a look there. And as we can see right here, you see on the left side that the DNS server has a dedicated IP address, seclab.net. And this system is actually set for a dynamic host, DHCP. And so there is a DHS mismatch, as they do not match up from here to here. And that's what's resulting in our lack of connectivity. So we can resolve this various ways, but how I chose to do it was I forced a match with one another by changing it in a manual setting. So how I did that was I got the credentials for the DNS server using an ifconfig command. And then I was able to get the metrics that I needed to come back here and make a manual entry. And I chose the DNS server based off that previous slide, what that number was, and put seclab.net. And as we can see here, so this is our troubleshoot, and this is my resolution for that. You'll see in the next slide, we have a successful connection, and this is exactly what we want. So that resolution was successful. Next, what we want to do is we want to identify the three main players in the system, which are the CEOPC, the web server, and the DNS server. We want to know, what the operating systems are for each for downloading software, future patches. We also want to know their identities. So this is some simple commands to make that happen: if config, IP route, and then for the CEO PC, we're able to actually find that in the PC configuration and information. Same thing with the web server. Follow very similar commands, except for this one right here, to get that it is actually running off Ubuntu and not CentOS. Now, the DNS server is actually running on the same version as the CEO PC. So those are just a quick way to identify the three nodes in the network. Now we want to test for file transfer. So of course, we want to be able to see if simple files can be accessed and shared across nodes in this network. We'll do this by employing an FTP file transfer protocol in this network. And as this example shows, the FTP was successful in connecting with, this is the ID for our web server, which is where it's downloading the file from. Downloaded the file. This is the file name. It's a policy file. So that was successful. As you can see right here, the transfer occurred, and we want that. That's what we want. We want to be able to share files. Next, we want to be able to see if new users can be added to the system and if they're safeguarded from other places. So here in the web server is where I'm adding the new user. I used a basic command, user add. I chose my name and my favorite number, and did the same thing for password, and then inputted those again, and it was successful. So to check that, I ran a command and was able to find that there is indeed my username, and the X formatting denotes encryption, so it is also considered safe. So this is what we want. We want to be able to add new users. Now we want to check to see if there's any protection from untrusted networks. That was the rest I was telling you about, the outside world. Are we operating safely, safeguarded from that? So we have the trusted Kali machine that was adjacent to our user, and we want to identify its IP address. So I followed similar commands and got its IP address. And then we'll do the same thing for that untrusted Kali that represents basically the rest of the world and get their identifiers. We've done that here. We'll use that information in the next slide. What I did was I pinged each other. That's basically a signal sent out to see if they can be communicated with. Well, the trusted did communicate with the untrusted, which makes sense. We trust ourselves, right? It's pinging out. But when we went to the untrusted machine and tried to ping back the trusted, we have 100% packet loss right here. 0 were received. The ping was unsuccessful, but this is what we want. We don't want the untrusted to be able to ping the trusted, right? So this is a safeguard that is operating as intended. However, there are network vulnerabilities. So we're going to discuss that now. So there's some points to ponder. We're going to employ the Nmap tool, which allows us to see the open ports in available servers. So the first Nmap that I did was for the DNS server. And as we can see here, there are only 2 open ports. That's not bad. There's only 2 points of entry. That's low, relatively secure. Next, we look at the web server. And we find many more, 23 or 24, I think I counted, ports that are open on the web server. And that's a lot more points of entry that we must consider in terms of security, and that these are many more points where something can be taken from us or inputted into our system. So that's just something to consider. Next, we're going to actually conduct, we did a file transfer a few slides back to make sure that worked. Well, we're going to do the same thing again this time. And I wanted to see what kind of data it generates, because all transfers generate some sort of data. All activities, all transactions generate data. And we'll use a packet sniffer called Wireshark to analyze this data. And how I've set this up is I have the Wireshark looking at the user PC as well as the web server. and it gets to see all the packets that go back and forth between those two players. And what I've done is I've facilitated the same file transfer that we did before. And I want to point something out here. We did the file transfer. This is it being deployed. And here credentials are being asked for. Okay. You see that the user is being inputted as Jasper, but the password is not being shown. That's what we want. We don't want the keystrokes to actually be logged or at least visible. And then we see that this has been, the file transfer actually occurred. Let's look at the Wireshark returns here. So this is the results in Wireshark and directed at that transaction. And I want to make a serious point about this highlighted line, item 27, that I have highlighted here on the screenshot. As you can see, here's a user, and the password is visible. Too hard to guess. And so this is of great interest to us in ensuring that the network stays secure, because this is a vulnerability in that those credentials are visible to someone who knows what they're doing. So we need to address these in future stages. So some final considerations. Network virtualization is easy to implement and expandable for business solutions, such as yours today. We have configured and installed a logical single firewall secure virtual private network for you and your team to start using today. We've confirmed its function and security from the outside untrusted networks. Your data is in safe hands, but it's relative. While good, there are even more safeguards to consider for the network's internal activity. We can add more router firewalls to further harden the network. We can use safer or more encrypted data sharing protocols that will ensure end users' information is safer from outside and nefarious forces. So there's more to come from our team to yours as we navigate future iterations. So thank you for your time and your consideration in my presentation today. I'd like to do a quick demonstration for you, as I discussed earlier, so you can kind of see really quickly how this Oracle VirtualBox looks. This is how it looks right here. I've got the router, firewall, the DNS server, and the web server. I loaded them up in that order because that is imperative. The users who will use this VPN should know that. And we're going to go ahead and launch the CEO PC. Now, in total, this should take about a minute, given how my computer is running today. So bear with me. We're just going to wait for it to do its thing. And what I'm going to do here is once I log into this terminal, I'd like to launch Firefox and access the DNS server to show its utility that is functioning properly and ready for utility today. That's what's important, is that when I walk out this door, you guys can start right away. And you'll notice here in a second that the operating system, here it is right here, CentOS 6.4, as the DNS server uses the same. And that's important. Like I made a note before that, if you have to get any software, make any changes, understanding the operating system, and knowing that pretty quickly will help streamline things. I'm sure you all know that, but anyways, I'm talking too much here. Let me go ahead and get this logged in here. And these interfaces are very elegant. We're going to go ahead and launch Firefox here. And we're going to make sure that our DNS server is working as intended. And there's a demo of that as well. So moving forward, really happy with this relationship. And if you have any troubleshooting needs, please reach out as soon as possible and we'll be in touch. So thank you and have a great day, everybody.